Hello guys, in this small video I will show you some insight into the making of this breakfast Renderman scene, and I will keep it short, and so yeah, you can imagine what I've done, and you can also learn how I use Cryptomatte inside of Houdini and Renderman, and some insight into the color grading process at the end. So let's get started. So what you see right here is the final render scene. All of the objects are converted to USD. So I use my traditional method to export them as USD and then convert them to packed primitives, which really helps to get really fast loading times. And to show you how I use the Cryptomatte, this is very easy. So you need to do the following steps. First, you need to open your shop context where you already have added your RisNet, and there you need to add a pixel sample filter. So no, a sample filter, not a pixel filter. And this is called Cryptomatte. And this Cryptomatte, you need to specify a render output path. You can also use the expression language when you have an animation or something like that, like in all Houdini render procedures. And I already did that with the final image, and yeah, that's basically the path to the output. Keep in mind that every time when you render the image, also in IPR, that Cryptomatte will proceed. So when you just try to do some tests and so on, keep it deactivated. So the way you add this to your render output is quite easy. You take your RIS node, and in the advanced section, you need to add the sample filter Cryptomatte. So that's basically it. To the settings of the Cryptomatte is one thing you need to change, or it's up to you if you change it. But I use Cryptomatte on material basis, so I choose the material option. So every single shader get a different ID on Cryptomatte. So yeah, the render process itself will take a bit longer. In my test, about 10%, but that's totally okay. I mean, you have so much advantage with Cryptomatte or with any advanced masking method. So, and yeah, what you see right here are in the scene are not all the objects which I've scanned. I needed to delete most of the duplicates, and as you can see, I already created a library. This is the library which I will distribute, scan volume 1. And here are all the shaders for all the objects, including the procedural generated objects like the basket. And yeah, this, for example, is the entire network for the basket. And it's also subdivided at render time, so don't wonder when those edges are quite sharp. And I have optimized the scene a lot to render faster. And yeah, I also added in another pass some smoke to the coffee, a very slight smoke simulation, and some tiny crumbs and so on with a simulation network, basically particle simulation, not a big deal. And yeah, after rendering, which took about 4 hours in 4K with 128 samples, or I can show you the settings. So I hope I don't change them. Yeah, those are the final settings. I mean, in fact, I could raise the pixel variance to 0.01 or something, which will increase the render performance. But in that case, for a print image, I thought it's better to have all the options and the perfect quality for a still image. That's why those settings are quite high. I mean, in the animation, I probably would go to 64 or something like that. And I also raised the default ray depth on both specular and diffuse, but I also tried to change some of the specifications on individual basis for some objects where I need those traces, right here for the glass example, for example. And yeah, I tried to optimize it. What really helps me during the render process was also to deactivate the light learning scheme, which is basically an advanced machine learning algorithm, which can produce artifacts in some cases. In my case, the problem was that some apples and some fruits are really bleeding out in color, and I can't reproduce what the problem was. So the problem was gone when I deactivate that. On my computer, it also renders a bit faster. I think this option is more optimized for multi-core machines with 12 cores or something like that. So yeah, sometimes in big scenes, this is really a good option, which is also default. So when you have very dense scenes with a lot of trees, for example, my cornfield and so on, this is really an important feature to be activated, but not on that simple scene. I call it a simple scene. And yeah, also when you use Renderman, it really helps and speed up your entire progress when you choose the override camera resolution option, so you can go down to 1/3 and you have a very, very fast response with this heavy scene from a texture standpoint and displacement. All of the objects, or most of the objects, have displacement and yeah, a lot of detail. So this really helps to be able to light the shot in real time. I also deactivated incremental rendering so that my hard drive is able to read the data and not stuck on the loading process, so the overall render time is decreased. When you have such a dense scene from a texture standpoint, it's sometimes important to deactivate that. But yeah, so after rendering, I loaded everything into Fusion, and I will show you some stuff that I did in the compositing. The first stuff that I did was I denoised the entire image. When you load the original rendered image, you will probably see that the image is quite noisy. So yeah, let us close this. So this is the final raw image. I mean, the resolution and the amount of noise is quite reasonable and is nothing unexpected. I mean, even really good camera footage under some lighting conditions can produce a fairly heavy amount of noise. So this is totally okay, and this is what you should aim for. So yeah, after that I used the Renderman denoiser, the single frame denoiser, and that's the result. All the noise is gone. I can't see any noise anymore. Also the glass and the refractions and the the subsurface scattering and so on. What I found out with the glass, with the subsurface scattering of the orange juice in the glass, is that under some lighting conditions, this fluids can overblow in lighting. I don't have the time to find out what the problem was, so I dealt with it in compositing, which I show you now. So this is the Cryptomatte export, and those are the changes which I've made. So right in here I dialed down the gain of the orange juice, and I also used some other stuff like this. I enhanced the reflections based on the variance file. So this is the reflection path of the variance file, and I did some other stuff like here and changed all kinds of things. So right here I added some additional occlusion, which is maybe not needed in a realistic sense, but I have added it to add some depth to the image. And yeah, I changed the brightness with the Z value depth channel, and I guess I also added some color. I don't know anymore. So I changed some of the coffee color right here, and also edited everything with ACES on Rec 709. So you have to look. So this is the okay. Here I changed the coloring of the bun a bit. I blurred the bun a bit, and what we have here. Okay. Here I changed the color of the kiwis. Now more saturated a bit. The direct lighting reflection was a bit too much. So here I changed some of the original model had a very black trunk, so I corrected this in this image. Sometimes you need to do something like this. So here I have added some tiny additional stuff with the DVE, and I have also changed some stuff on the apple, because this is a bit too much. I don't know why this is outburning so much, but I guess this is because of the subsurface scattering. I don't know exactly, but apples are a really uncanny valley situation stuff. So yeah, sometimes it works and sometimes not. So I've changed that. And yeah, I changed also the shading a bit of the apple. I added a little wax coat onto the apple. And here I've changed the marble underground. I added basically a second layer of diffuse marble on top of the original rendered marble. So this is not that harsh anymore. So then I did an intermediate cache, and then I added some additional defocus. I mean, this is the original defocus, and this is with the defocus tool, which you can get in the reactor user database. So here I enhanced the entire defocus and changed also the sharp zone. So this is basically the sharp zone now. This tool is similar to Nuke, what you have in Nuke basically. So here I added a lot more of the defocus. I also like the circular defocus highlights and so on. And then I added some additional glow to it. So this is the glow path, the glow path. I added my lens reflection or dirt mask, which I have created in Substance Designer. And I added a little highlight, a smartphone highlight, onto the knives. Here, right here. Yeah. And then I added some tiny printing onto the napkin. I mean, the napkin has really high detail. I mean, you see all those fine detail right here in the normal map. Also the subsurface scattering and translucency on the napkins. I tried to make it somehow physically plausible. And yeah, here I added some of that ink, and here the second layer, a breakfast with Renderman. And at the final end, I defocused the area where the steam from the coffee should be. So I added very slight defocusing, and later I added the steam itself. So this is looking much better now. And after that, I loaded everything into Davinci Resolve. And here we are back in Davinci Resolve, and here I basically imported the image and I converted the image from ACES to Rec 709. Then I reduced the saturation in all black areas or in all dark areas, which is a common thing on grading real photography and filming footage. And yeah, I did some, that's not working like in Fusion, so my bad. Then I changed some of the stuff, added some chromatic aberration, a gamut control, a lens reflection, some additional curve stuff, and some lens distortion, a vignette, some additional lens refraction. I added a bit of sharpness to the entire image, so this is basically the graded result right now. And when I add some post sharpness image, you can see a slight increase in sharpness, and yeah, then some grain to it, so we have some sense of real photography. And then I converted everything. I think this is useless, this node, but yeah, okay, I have it in here. And yeah, that's the final result. I think Davinci Resolve is quite important in doing such stuff. What I can also show you in that video is something quite important, which I have discovered recently with Davinci Resolve. You can retime shots. That means you can save render time, really a lot of render time. So I will show you now some results of the retiming process. So yeah. So what you basically see here is quite easy. All you need to do is you load in your rendered sequence, which was only 49 frames in that case. And then of course you activate the retiming controls. And here you see I have dialed down the speed to 10%, which means that I can render every 10th frame in Renderman to have original speed. When I would change this to 25%, that would mean or require to render every 4th frame, and so on, 50% every 2nd frame, and so on. Of course, you can also use your own percentage amounts like you want. But yeah, every 10th frame or every 4th frame is really, really nice, because you save. I mean, this is crazy. And yeah, what you see here is a really, really decent result. I mean, the computer is starting to recache this entire stuff right here. Yeah, so be back. The computer was a bit of lagging right now because I have deleted the cache from Davinci Resolve, so Davinci Resolve started to recalculate the retiming. So this is the original footage, and I can try to import the result. Wherever I have it. The config is here. And this is probably, this is the result. I mean, from 49 frames to 489 frames. I mean, this is insane. This is awesome. And this is really working with Davinci Resolve. So to get the option, you only need to do 2 things. First of all, you import your sequence. It should be a 16-bit sequence, or better a 32-bit EXR sequence. This is to be turned out the best input format. And then you have a toolbar on the right, and here you need to double click the retime and scaling section. Then this will open, and here you need to choose to retiming process optical flow, and on the motion estimation you need to change to speed warp, and speed warp will, in combination with the optical flow, turn your GPU to 100%. You need to have an NVIDIA device, a NVIDIA GPU. OpenCL isn't working. This only works with CUDA cores, and of course it's optimized for RTX cards. And yeah, and then I cranked it up to a bigger size. So, but that's the result, and you see, because of the recording, okay, it's lagging a bit. I think that's because of the recording, but it should play absolutely smooth, and you see no problems. I mean, right here, when we look at those highlights, there are no occlusion problems, no sketchy things. It really works. You can see some tiny issues around highlights. It sometimes morphs the highlights a bit, but that's totally okay. I mean, yeah, here we see it. A normal user wouldn't see this. Also not in motion. So yeah, I can also show you another example from a different project, and I think I need to blur that a bit. Where is my earth? So this is just another example. I use the retiming for rendering my earth sequence. I also used grid markets to do that. And the result has 960 frames. The original input was 240 frames. So I basically decreased the speed by 25% and used the retiming methods right here to get a final result. I mean, the result looks, it looks like natively rendered. So there are no problems. Even in such a hard case with a lot of blacks and so on and so on. It really works. So this will help you to speed up your overall Renderman process. I hope the stuff helps you. I wanted to do this tutorial or quick tip tutorial much earlier, but in recent weeks my voice was completely away and I was quite ill, so I have now recovered a bit, and so yeah, I keep my promise and will publish this today. So yeah, have a nice day and stay safe, and also stay healthy in this current times.